Hello. So today we'll be doing minimum depth of binary tree. Given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Note, a leaf is a node with no children. Since we've been doing like the level order traversals, since we've been doing breadth first search, I will be implementing the solution using breadth first search. There is a depth first search solution. I could make that maybe tomorrow or something, but yeah, with that being said, this solution, could be longer, could be shorter. It really depends on how the trees are implemented, but yeah, so we will move forward with the breadth first search solution first. So for very, base case situation, we'll do if root is none, then we're going to return 0 because, if there's no root, there's no depth at all, right? So it'd be 0. Other than that, then we know we at least have one node, and we will move forward with that in mind. So we're going to start off with depth equals 0. The logic for how you calculate depth could be slightly different. This just makes the most sense for me. But yeah, and then we're going to create a queue like we always have using dequeue. Queue.append root because we gotta append the root in order to be able to figure out essentially which level has at least one node with no children, right? And so while the length of queue does not equal to 0, this just tells us we have nodes in our tree and we need to be able to sift through there in order to, I guess, find our solution. And we have a clause in the middle where we do break out and return early. So we're going to do depth plus equals 1 because if we get in here, we know that we have at least one node. And looking at this, we've already checked that root is not none because otherwise we would have returned here. And so we're guaranteed to have one at least here. So we're going to increase our depth by 1 and we're going to calculate length. The reason why we need to do this is because throughout this while loop, we're going to have another loop for I in range of length, right? If we were to use a while loop here, it wouldn't be good because we have this here, length, and because we have the queue, right? And then in here, we're going to be appending more nodes. And although it would be right if we were to just set like a length and then while the length variable is less than a certain number, whatever the length is calculated here, that could work too. I mean, that is what we're doing, but I think it's just a better practice to use a for loop as opposed to a while loop, because while loop, if you don't handle it correctly, you can be stuck in here infinitely. And so here we're going to do node equals queue.pop left because we want to take out the node. If node.left is none and node.right is none, then we're going to return depth. There could be a different way to solving this. Not 100% sure, but this makes the most sense to me, and these are all should be all O of 1 checks, so shouldn't be too bad to do anyways. So now basically, if they're both none, we can return the depth here. We can return the depth here, right? And we only get here if we don't return above. And so that means left or right, or both, are not none. Right? So we're going to check whichever one is not none or both, right? And then we're going to append them into our array. And so this just handles for all the nodes that we've calculated for length. And if we haven't returned yet, we'll just go loop right back. And this should never happen, but it's just to have, I guess, some IDEs will complain about not having a return that's like not, what would you call this? Like condition locked. So yeah, I mean, worst comes worst, you just never go in here and then you just return depth of 0, which should have been handled here anyways. But yeah, this is just something that you probably should have, just, you know, in case some compilers do complain about not properly handling for a return that's not condition locked. But yeah, this looks about right. So if we were to submit this, it works. And yeah, thank you for watching.